We were founded in 2017, and now we have 280 members that pretty much companies, 280 member companies who rely on RIST day in and day out. So thanks to the core contributors and to all the contributors worldwide, we really appreciate the support. We're going to have fantastic presenters today. First, we're going to have Dr. Cyril Naroya, who is Cobalt Digital's CTO and also the RIST Forum president. Dr. Cyril is going to cover the basics of what's RIST, and he's also going to get into point to multi-point content distribution using source adaptation, which is one of the latest technical recommendations developed by the VSF group, the AG group. Dr. Kiran Cunha, CEO and founder of Open Broadcast Systems, and Kiran is also one of the RIST Forum directors. Kiran's gonna talk about how to achieve reliable delivery using ISP diversity. So that's gonna be quite interesting. He's gonna try not to be too technical, which is hard to believe. Mr. Mo Goyal is Senior Director for International Business Development of Evertz, and he's going to cover pretty much a quick overview on various RIST field deployments that they have experienced. And Mr. John Dale from MediaLinks, he's the Director of Business Development with MediaLinks. He's going to basically explain why MediaLinks chose to adopt RIST. So we're very excited to have these speakers. Thank you so much. We encourage you to participate on the webinar. Please go on the chat or raise your hand or however, or just unmute and ask some questions. We'll take a second at the end of each speaker to take some questions, but also we're going to take some questions at the end and hopefully have a good discussion, before we end the session today. Thank you very much, everyone. And Dr. Cyril Naroya, you can have it.
All right. Thank you, Susanna. So I'm going to start with a quick introduction to RIST. I mean, some of you are familiar, some aren't. So this is not going to be a long, detailed technical explanation, just a very quick overview, because the webinar today is about applications. So this is a slide I'm very proud of. I made it some time ago, but I always use it. Shows the relationship between the technical people and the marketing people. So the RIST activity group is in the context of the VSF. The RIST activity group creates the specifications. Known caller. And then the RIST Forum does the marketing, gets the word out. So companies can participate on one or the other or both. Me personally, I'm the editor of the RIST specification on the AG side and the president of the RIST Forum on the marketing side. So I wear two hats. So what have we done? So RIST has been, well, since 2017. The AG was created in 2017, and we've done all of that. So we started with a TR-61 RIST Simple Profile that came out in 2018. That gives you the basic reliability. I'm going to talk more about that. Then we went with RIST Main Profile, which we published in 2020 and updated in 2023 with some minor editorial things. And then we went into RIST Advanced Profile, which was published in 2021. Then we started working on what we call the ancillary features, so things that don't fit specifically in a profile. And the first one was source of adaptation, TR-64 Part 1, published in 2022. I'll talk about that in my talk. If you like WireGuard, we created the specification for using WireGuard in RIST that came out last year in 2023. If you want to go over firewalls and you don't want to talk to IT, there's the RIST Relay, that's Part 3, was also published last year. We just finished publishing decoder synchronization. I actually have a paper on that in the Safety Imaging Journal last year. So technical details are all out. This talk is not about that, but if you're interested, it's out there. And then there's Part 5, Multicast Discovery. We published it a little bit before Part 4 because it was simpler, came out last year. And now we're working on satellite hybrid delivery. I will have a talk about that at NAB if you're coming, at BEITC. And we're starting to scratch the surface on risk control. We may do something with the NMOS people. We don't know yet how to do that, but we are working on it. So what's on each profile? Very quick description. Simple profile is got packet recovery through ARQ. It's the very simple thing. I didn't get the packet, send it again to me. The other important thing in simple profile is native multi-link operation with bonding and seamless switching. I'm not going to go into details on that because that's Kieran's talk. So he's going to show you how to do that right. In main profile, you have flexible networking. So that's we introduce a concept of RIST tunnel and multiplexing. Main profile gives also security to DTLS or PSK. And then you have multiple authentication options because you need to know it's not just encryption. You need to make sure that the other side is who you think they are. Then we come into advanced profile, and I do talk very fast, so stop me if you have a question. Advanced profile gives you the ability to run any protocol over RIST. It gives you a link that runs RIST. So it's almost like a VPN with retransmission, with more security options and payload identification, so you can run stuff natively on advanced profile. This table is an IFO. Our RIST AG chairman, Rick Ackerman, says that we use the Lego approach, right? If there's something that's already created, we use it. So this is only simple and main profile. There's another list for advanced profile that I didn't bother to create. But I'm not going to read all of these, but it tells you it shows you that as far as possible, whenever possible, we use standards. We built on top of standards, and we only invent something when it's necessary. One of my friends once said that a good engineer is a lazy engineer. So I subscribe to that. All right, unlike, here's a nudge to other standards bodies. Unlike the others, you can access the RIST specifications for free at the VSF website. Videos, so you can just go there. They are all free of charge, and they have recently reorganized, so they are in a nice order. All right, enough of that. That was the 5-minute elevator pitch for RIST. We have plenty of other presentations that go in depth, but this one, I'm now going to go into an actual customer deployment. And I will ask Kira not to laugh at some of the stuff I'm going to say. So what is this customer? This is an actual customer. I'm just not going to say the name. What did they want? They had very traditional HD video, 1080i with embedded audio. They wanted to encode to MPEG-2 and Adobe AC3 stereo. That is kind of old school, but that's if that's they want and they have money to pay, we sell them that. But they want to distribute that to 3 distinct locations using the internet. They wanted to output SDI, so SDI instead SDI out, but just for monitoring. But what they really wanted is push original stream over ASI, which is another very legacy throwback. But again, I heard the ASI was dead 20 years ago, and that is not the case yet, but Kira wants to do it. So this is what it looks like. I'm doing a little bit of advertisement for Cobalt. We have an encoder on the left that's sending 3 independent streams, and we put 2 boxes on each side. One is a decoder that is creating the SDI, and it's turning around the RIST to a very traditional, simple transport, CBR transport over UDP to one of our legacy gateways. It gives you ASI. So there's 3 sites. The 3 sites look the same. I just opened one of them. So this is actually what looks like. That's what got deployed. And RIST is using on the internet. So which RIST technologies do we use? For reliable transmission over the internet, TRL61 simple profile. They didn't care about encryption because this was going to go on air anyway, so it doesn't matter. It's in the clear. No packet deletion. It's is a feature. I didn't talk about that, but it's a feature of RISC main profile where you can change the video bit rate without while producing a compliant CBR transport stream. So you don't send the no packets, but you send a marker in the head to say where they were, so the other side can put them back. So CBR in, CBR out, but you can now modulate the bit rate. So that's in VSF TR-62 RISC main profile. And then we added dynamic video bit rate changes based on network traffic, which is TR-64 Part 1, a RISC source adaptation. And you have presentations from me on that, and the TR is out. It's been out for a while. You can go download it if you're interested in how that works. So it's not just a change of the encoder bitrate, it's change also on the path. It's very interesting TR. You should read it when you have a minute. Okay, how does that work? So I don't have data from the customer site, but I have data from Cobalt. So I'm going to show you how source adaptation works. It's not from site. So Cobalt's got an office in California, in Santa Clara, and main headquarters in Champaign. So we can always transmit that. I had an encoder set to go between 8 and 2.4 megabits per second. The RTT round trip time is 75 milliseconds between these two sites. RISC has an echo message, just like a ping that can measure that. So that came from the RISC echo message. And I run it for 64 hours, although I'm going to just show you results for the first 45 minutes. 64 hours is more of the same. And in Santa Clara is a Comcast modem. So it's a traditional consumer grade cable modem. This is how it looked like. I mean, it started, it goes at 8 megabits per second, sees that it can't do it, and then adjust the bit rate over time. So it's 64 hours of this. This is the first 45 minutes. You see here, sometimes they can go at 8, sometimes there's too much packet loss, and then it tries to go up. So that's one of the things with RISC. RISC did not define this algorithm. It's up to you to define what your strategy to adjust the encoder bit rate. So that's more or less how it works. It never went down to the floor to 2 megabits per second, but it stayed here around 5, 6 for most of the time, and that's dynamic changes. With no packet deletion, you can have a CBR transport stream coming out of the decoder. So if you're pushing it over ASI, that's a well-defined CBR transport stream, which what you're changing is the amount of nodes, which you didn't transmit. This is how you adjust the rate. So I'm going to stop here and see if anybody has a question. Otherwise, I will hand it over to Kieran. Any questions now? Not? You have the floor, Kieran.
So hi, everybody. I'll go back. Yes, my name's Kieran Cunha. I'm the founder and CEO of Open Broadcast Systems. We are an encoder and decoder manufacturer based in London. Really, that picture should really change that. I don't think that's London, but anyway, it's like Hong Kong or somewhere, Shenzhen, not Shanghai. Anyway, yeah, so I'm going to be talking about how to achieve reliable diversity delivery using ISP diversity. Next slide. So why does ISP diversity matter as a concept? I'll just set this up. Using multiple ISPs is important for high value content. For example, if you're in the US, ideally you'd want to be able to send on Verizon and AT&T at the same time, or here in the UK on Virgin Media and BT. And this means if one ISP has an outage or packet loss or any other kind of issue, you're protected by the other. And these days, it's quite interesting because when RISC first started, this wasn't really a thing, but these days you can also use other types of transmission technology, such as 5G and Starlink, which are not quite as good as wide links, but they're tending towards getting as good, which is really interesting because it means you could even have diversity at the physical layer. So often in the street, a backhoe can go through multiple fiber cables, and that's very common. And so with ISP diversity, this certainly reduces the risk for high value content. This, of course, isn't a new concept. We've been doing this for many years with what's known as SMPTE 2022-7, also known as hitless switching for managed networks. But what many people are doing is taking this existing architecture and translating it directly to the public internet. And as I'll kind of explain in the next couple of slides, and we'll get quite technical, we'll have some diagrams explaining the details. This doesn't, 2022-7 does not extend directly. The nature of doing things like retransmissions, as Cyril explained, doesn't extend directly. And what really matters is the architecture behind this, in particular, choosing a protocol that's got native support such as RIST. And this makes a big difference to performance. And it's worth pointing out the consumer industry is quite far behind this at the moment. So your other consumer grade protocols, SRT, RTMP, WebRTC, they're a long way from this, which is kind of funny because consumer sort of user generated content, Twitch streamers also have, in some cases, the same level of desire for high reliability as traditional broadcast, yet they're still a long, long way behind an understanding of using multiple ISPs. Next slide. So let's look at a traditional SMPTE 2022-7 architecture. So on my left is a sender, and on my right is a receiver. And conveniently, this is traditionally known as a red-blue, or very conveniently, you could have red for Verizon and blue for AT&T, or red for Virgin Media in the UK and blue for BT. So the same packets are sent over both networks. They are sent into input buffers where the receiver combines two independent flows. And so if there are any packets lost on either link, they can be recovered. They can be recovered not actively, so not through a retransmission, but they can be recovered by looking into the other input and finding that particular packet using what's known as the RTP sequence number. So next slide. So let's now add the concept of retransmission. So I've put these two diagrams side by side to show what's a bit different here. And what's happened is, as you can see, if you, I don't know if you can zoom, I know it'll be this, you can't see my mouse, but what's happened on the left is there is an output buffer now. So packets are being held in this buffer in case a retransmission is being requested. So I've put the retransmissions in green, and I've made the line a little bit thicker because they're almost certainly at a lower data rate. And so, yeah, you can see it's a similar architecture. So packets are, again, it's an active setup. Both networks are active, but if you do this naively, unfortunately, you have a problem. Next slide. So let's expand this a bit more. Unfortunately, the two input buffers I've put in dotted lines, unfortunately, are not aware of each other. So this is what a lot of people are doing today. They're setting up two independent SRT sessions. These two sessions aren't aware of each other. So this is very suboptimal because, for example, if path A is clean, if Verizon is clean, but AT&T is losing packets, it doesn't matter in the real world. But with two independent sessions, that means path B is still trying to recover packets because the system doesn't know about the other side. And this overall has a reduced set of packet recovery capabilities. The sessions are independent and not aware of each other. And the problem is when both links are having issues, you're now wasting packets, wasting bandwidth, wasting limited recovery bandwidth on potentially recovering packets that you already have. And that's because there are two independent flows into the same receiver. So this is why I call it the naive 2022-7. So this is taking a legacy technology and trying to use it in the modern world. This is like taking a fax, trying to, making a document, scanning it in and sending it as a JPEG in an email. It will work, but it's inferior to, actually writing an email and sending it electronically. Next slide. So let's look how, if you want to do this properly, this is how you do it. So let's compare the difference. And there's only one actual change, which is the packets go into a single bucket at the bottom here. So I put that in a dash line. And that means now the receiver is aware of these multiple input flows. So this is an example of RIST multipathing, or one of the new unstable SRT features, which unfortunately they've called bonding. We'll talk a bit briefly about bonding later, as bonding is actually a completely different concept, but unfortunately they've used the term a bit badly here. So next slide. So the receiver is now aware of both links. And that means it will only request retransmissions when packets are lost on both links. And that means that whenever there's an issue, it can also actually request a retransmission on both links at the same time. So that increases the probability of a packet actually being recovered. And this is, especially during a difficult network situation, substantially better packet recovery than a naive approach. And this is what's particularly important for high-value content. It's about that unfortunate situation when Verizon and AT&T have a brief issue. And as you know, that will be, that as Murphy's Law says, that will be during the Super Bowl final or during, you know, Messi's goal. And so you need a packet recovery protocol that has the highest chance of recovery. So doing two independent links means that both links are just, they don't know about each other. So you're wastefully recovering traffic on data that you already have. And overall, this is a substantially better packet recovery than the naive approach. And one of the things RIST is RIST is capable of doing. Next slide. So we do this for real with quite a few customers. This is a real world transmission at 35 megabits between London and New York using two ISPs. May well be Verizon and AT&T, I'm not sure. But as you can see, over the period of 9 months, they had absolutely 0 packets lost, over 90 billion packets. So during this period, both ISPs actually had full-on outages, I think, for hours on end. But the stream was unaffected, as you can see. There were quite a few recovered packets, but zero packets lost. And for those of you familiar with transport streams, no continuity count errors as well. So this is remarkable. You can do multiple ISPs for real, 35 megabits, again, high value content. This isn't just a sort of low bitrate feed. This is high quality contribution. I think even 422 10-bit this particular stream was. So the stream was completely unaffected, even with, you know, relatively long outages on both ISPs. And so it's really important that you choose a protocol like RIST that has, if you care about your high value content, that has support for multiple ISPs. Next slide. So conclusion, multiple ISPs are important for high value content. You have to be careful with the design to ensure the highest error recovery, because you will need the best error recovery for that particular moment where you have millions and millions of viewers and it needs to work. RIST is the only open standard protocol with native support for multipathing. There have historically been other proprietary protocols like Zixi. But it's worth saying SLT, whilst they have released the feature, it's still an unstable feature. And don't be sort of convinced by a lot of the hype around consumer protocols like, oh, we're going to use WebRTC, it's amazing, or RTMP, because these things are not designed for professional video applications that matter. So going back to the technical side of things, traditional broadcast 2022-7 does not map directly to the internet. You can't quite take a fax machine, scan it in, and send it as an email. It's not quite the same thing. And so some care and attention is needed. We and others have had RIST multipathing in production for many years. I won't go into bonding. I don't want to complicate this discussion anymore because 2022-7 is sort of the baseline of where everyone started. But there is an approach called bonding or load sharing, where you actually can share load between the providers. So this is regularly used on 4G, 5G, and Starlink. So in this example, perhaps you have a 4G connection, a 5G connection, and Starlink, and maybe you want to put 1/3 of the traffic on each one. And then if a particular one has an issue, you move the traffic over dynamically. And this is, again, something that RIST is capable of doing that other protocols are not, certainly none of the consumer protocols, and not SRT either. So yeah, hopefully that was a useful introduction into the way multipathing works in RIST.
Thank you, Kieran. I'm going to stop here for a second and see if there are any questions for Kieran. All right. So we move on to an overview of RIST field deployments from Mo Goyal from Evertz. Take it away, Mo.
Thanks. Yeah, just if we move to the next one here, we'll talk a little bit about what we've seen in deployments. I think one of the elements we want to show is that RIST is being deployed in real world applications. I've got a couple different types of applications that we want to highlight. So a little bit of background on, I mean, Evertz is pretty much a known entity in the broadcast space. We have been also moving a lot of our traditional technologies that you would find on-prem into the cloud. And it was really that effort that we did that really sort of highlighted the need for a reliable transport in and out of some of the services that we have within the cloud, but more so also inside the cloud, and handling the different challenges that are within the networking between different availability zones and things like that. So what we've seen here is some deployments we've done over the years. Again, really starting from the play out side of things, where a lot of the early adoption of cloud has been in that space, and we start to see this moving closer into the production. So we anticipate seeing a lot more production applications of RIST as well. So if we kind of go through the first one here, if we step into this, we'll look at sort of three different companies looking at or implementing this to date. So if we go to the next slide, we'll look at Blue Ant Media based out of Canada. We'll also talk about some of the things that Fox is doing, as well as a SaaS service that we provide in terms of Evertz.io. So let's start off with Blue Ant and go to that one. So a little history on Blue Ant. Blue Ant is a Canadian broadcaster, broadcasting and media company. They both have linear playout channels. They've got production elements as well as a print media. They basically are distributing BBC channels, so BBC Earth in Canada, BBC First. They also have their own channels that they generate, which is Live or Cottage Live, Love Nature, Make Full, Smithsonian, and T+E. They've also been moving their content onto fast channels. So again, taking advantage of the ability to distribute that across platforms like Roku. And they have a number of content that they create and publish on there. They also have a compiling or print media that goes with it. So it's a big company that creates content that is not only just distributed within the Canada, but also feeds channels internationally. So they do take content and distribute that across. So if we look at the first one, and we go to the next one here, this is an example where, as a publisher of BBC content, they do take in live events from the UK, things like the coronation, the Queen's funeral, and other live events. So this was an example of where they have a production element that's being created in London, and they use a third party, for example, Global M in this case, to stream that content out. And that content comes into their facility in Toronto using one of our XPS technologies, which will take that RIST and feed it back into SDI. So that comes into their Toronto facility, and basically within that production facility, they have our playouts. If we go to the next slide there, essentially those streams come in and basically feeds into the linear playout. So those are live streams that go in and get interjected into the regular scheduled programming. And again, this is for those live events that are happening in London, but also annual events like Stand Up to Cancer, which is a large scale fundraiser. So for contribution or live feeds that are coming in from remote locations, RIST is the choice to carry across the network bandwidth they have, and it feeds into their traditional linear. The linear platforms we have, Mediator and Overture, were the platforms that we have both on-prem and moved into the cloud premise. So in this case, we have sort of a number of native interfaces. So some cases it could be SDI if it's on-prem. It could be 2110 while it's also on-prem. But once we get into the cloud side of things, you typically see it as RIST as our ins and outs, as we look at for a reliable transport. And again, this is something we looked at since the sort of early days of RIST, and sort of continued to participate with the RIST Forum and deploy that across this platform. So from a contribution or bringing live content, that is one key mechanism there. On the next slide, if we go there, the distribution of it. So as I said, they generate a number of production and their own linear channels, for example, Cottage Life and a few others, and they distribute that to other regions around the world. For example, for South America, they take their streams and feed it through a provider in Europe, who then takes it across into South America. And for the African continent, they basically take that content, stream it out to a partner in South Africa, and then they distribute from those points. Taking the outputs of those channels, they use RIST and carry that across the network to the different locations. So from a distribution perspective, they're taking their final program and delivering that out to these different regions, and again, doing that in a reliable manner. If we go to the next one, please. So again, as I said, they are using this as a regional distribution. So again, looking at it from a to Europe as well as to Africa. And in this case, we have what we call our Cloud Bridge or 78.1 product, which will basically take the outputs SDI 2110 and put that out as RIST streams that they then use to distribute that out. So that's a great example of not only bringing feeds in, but also distributing that across from what we say would be a traditional facility that has on-prem playouts in their own premise there. So if we go to the next one, Fox is a known entity in the US. It's a large-scale broadcasting media company. They've got a couple of network centers. Sorry, there was a typo in this case. They have a network center in Pico, and they have a broadcast center in Tempe for channel distributions. They have a number of different channels, a number of different properties that they do, and those are the two main facilities. So if we go to the diagram here, one of the things that they've done is they've moved a lot of their channel playout into the cloud. So using our sort of Mediator, X, and Overture, those things that you would find on-prem are now presented inside the cloud. And they move content that they create into the cloud. They do the full playout from the cloud. So because there's also networking between different availability zones and different regions, they're using RIST to move that content between to sort of navigate some of the challenges within the cloud networking infrastructure. So the stability of those network connections can never really depend on, as we saw in the previous presentation, ISPs have some instability challenges. So RIST allows us to move content within different availability zones fairly seamlessly. So if we go to the next slide there, that kind of highlights a couple of that. So we've moved that playout technology that we saw previously in the BlueNet into the cloud. And the links that are going up and down, so content that goes in, gets produced and then brings back down, are using RIST, but also in between the different availability zones that we have inside the cloud provider. So this is really another example of moving content reliably and securely between the different elements so that we're getting the content there in time or there without any issues. From a distribution point, the outputs basically are coming in through RIST and gets fed through their various channels, as well as their fast channels that they generate is also being generated in the cloud and outputted through RIST. So the difference between BlueNet in this case is that same distribution mechanisms, except one's being done on-prem, the other is now being done directly from the cloud. If we go to the next slide here, as we have all those elements running in the cloud, it makes sense to then multi-view them or monitor those. So using our cloud MVP, we use all those streams and we feed them into a cloud multiviewer. So if we go to the next slide here, it basically takes all those RIST streams, generates the mosaic of all the incoming streams, the outgoing outputs, generates that, and then takes the output of that monitoring and feeds it back down to the different facilities, the network center in LA and the broadcast center in Tempe, takes those outputs of the multi-viewers, streams it down as a RIST, and feeds it into hardware that then takes it out and puts it into a 2110 or SDI feed that gets fed back into the broadcast facility. So they can have that into their traditional displays that are found there. So again, looking at a cloud environment and pulling the streams without having to take all those streams, bring them down is RIST. Keeping everything, monitoring in the cloud, and then taking the outputs and feed that into the prem gives us that ability to monitor those feeds as well. Last, we have Evertz.io, which is a SaaS platform that we are providing for customers, which basically is channel playout and streaming for anybody who's looking to spin up channels and without having to deploy the hardware on-prem or in the cloud themselves, we do that. So again, in this case, we are looking at running these services on multi-tenant and cloud platforms. We're looking at ways to do this reliably internally and a reliable mechanism to bring streams that come in from the different remote sources that they may have. So we use RIST as a protocol to bring streams into Evertz.io. So provider or content owners can take live feeds, bring that into it. We do the channel production, we do everything else for them, and then we hand them the output. as RIST. So that's kind of a sort of fundamental premise that we have within our product offering. And you can see it's kind of carried across multiple types of implementations. And that is kind of it.
Thank you, Mo. Let me stop here and see if there are any questions for Mo. All right, so we move on to our last speaker of the webinar, Mr. John Dale from MediaLinks. Take it away, John.
Thank you, Ciro. Yes, I'm John Dale. I'm with MediaLinks, and I manage our business development and product management team. So I just wanted to take a few minutes, and I've only got a couple of slides, to just talk a little bit about why MediaLinks embraces RIST. And from our perspective, there are several competing technologies that could be used for reliable transport. And I want to talk a little bit about why we feel that RIST is really really appropriate for the type of things that we do, and share that with you. So we're typically involved in working on high quality media networks, which access major venues and major locations and have high QoS and very low rates of packet loss. And in those cases, some very light FEC can deal with that. But as we see, and we have seen over the last few years, that there's more and more content coming out of smaller venues or remote locations that don't have access to the high quality media networks. There's more and more demand for content, and getting into the smaller venues and smaller locations where content is desired. We don't have access to the media networks. And in a lot of cases, we don't necessarily have the resources, the production resources, at the same place at the same time. So we wind up with more distributed production than we've ever seen before, and needing at the same time needing reliable real-time interconnection. And that's really the key. So how do we solve that problem? So let's go to the next slide. So we have a complex production. We may have access to high quality network, but we also may need to get to locations or contributions to the production that are over lesser quality networks at the same time. And these need to address video, audio, data, and voice, so that we have these real-time services that have to come over the network. In the past discussions we've had today, we've really been talking about moving content over the internet. But what we're seeing is that there's sort of tiers of quality in networks, so that you have media networks that are designed to avoid any packet loss. And then we have more enterprise or business networks that are still very high quality, but have somewhat more loss. And then we get into RF networks, mobile, satellite, microwave, and then the internet, which are all much more lossy. So we're doing a production, or our customers are doing a production, and they need to have services run over multiple networks, not just the high quality network. So that's where we're seeing that we need to apply some capability other than what we typically do, which is the SMPTE ST 2022-7 hitless switching, or 2022-1 or 5 FEC, but we need broader capability and better recovery capability than what those offer. So we can go to the next slide. So while 2022-7 and 1.5 can address reliability on high quality networks, they really can't address what's needed on the lower quality networks. And whether the lower quality networks are being used as a backup to the high quality networks, or we're trying to do reliable connectivity over multiple paths of lower quality networks, we still need some additional capability. And that has to be adaptable to higher and lower bit rates, depending on the connection and service requirements. So again, we need some scalability. When we look at over the internet, and it was mentioned earlier, that for a 35 megabit connection, all right, so that's a high quality media feed over a fairly low bandwidth path. In these cases, we could be using paths that could take up to 200 or 300 megabits, but we need a capability that's going to be able to handle the lower bit rate requirements and the higher bit rate requirements. And also work with 2022-7 so we can do primary backup capability. And very important, has to be able to support standard codecs and standard protocols. We don't want to be using a proprietary solution. So what we see additionally, and I think this has been discussed in this webinar so far as well, is that not only do we have to interface at the IP level, at the SDI level, but we also have to interoperate at the IP level. So those are all considerations in choosing a solution. Crossing boundaries from trusted to untrusted, like moving through firewalls, is also necessary, and the last bullet there on security and encryption may be needed. So in looking at all of that, RIST can address those with the simple profile or the main profile, not even with going up into some of the additional features. So that makes it a really compelling solution for these projects. And that's why MediaLinks embraces RIST, and we feel there's a good future in using RIST to solve these problems. So I'll stop there and ask if there's any questions.
No questions for John? Well, I have a question that a couple of people asked, which is always a number one question. I can tell you that right now. Why? And some of the attendees are great contributors, so anyone can answer, or multiple people can answer. But why would anyone choose RIST over SRT?
Well, let me start. I mean, Kieran, I think, made a very good argument for that. RIST is, I'll be frank with this. If you have just a little bit, few percent packet loss, it doesn't matter. Both are going to work. You need RIST when the going gets tough. That's when, if you have a challenging link, or if you want to do this seamless redundancy, the hitless redundancy right, that's when you need RIST. So RIST is more of a protocol, professional protocol. SRT is more of a consumer protocol. And the nice thing about RIST is it's multicast capable. Is based on existing standards, and it's something that also likes to say about technical debt. SRT is based on an old UDP file transfer protocol, so there is problems with that. But I could go on and on, but that's the bottom line. If your needs are simple, your link is good, anything's going to work. If you need something for more challenging environment, then you need RIST. Does anybody else want to add anything?
Yeah. Adi, we miss you.
He said he wasn't going to say anything today.
Oh my.
If you want to hear my opinion.
Yes.
Basically, SRT comes to replace the old RTMP, which was unidirectional in nature. So the focus is to take one stream or even maybe multiplex several streams, send them down the road. But if you need that bidirectional communication, sending KVM, other traffic, maybe audio downstream, and using only one link, the only protocol that gives you that right now, open source protocol, is of course RIST. And just like Kiran and John Dan mentioned, the fact that you have the Beta SMPTE 2022-7 capability allows you to have truly low latency, higher durability, and we can also touch base on security. If somebody wants to use higher security aspects like DTLS instead of the standard PSK, that is also available with RIST and not with SRT. So the SRT, as me and Kiran we often say, is good enough. If you want a good enough approach, you have a service that runs like a day, and you have a good conditions, by all means, go with SRT. If you need a professional, durable, adaptive, dynamic protocol that will allow you to scale up and down, have bidirectionality, more capabilities down the road, using a single connection or multiple connections, then the obvious choice will be RIST.
Yeah, and people can also always look for vendors that support both. And this way customers can evaluate and test either one and see what they want best, so they can buy both licenses and you know, always have a choice. I think a lot of the RIST members now offer both choices, so it's, you know, the choices, the options are always there, so people can go either way as they wish. Thank you, Cyril. Thank you, Adi. The one more question I would like to ask that also comes up a lot. The activity group is the technical portion of the RIST. The RIST Forum is the marketing, the AG is the technical side of the RIST. They, for those of you who don't know, they meet for an hour every week for almost 7 years, since 2017. So these guys spend a lot of time together, a lot of time brainstorming and coming up with everything you see and hear. So aren't you guys done yet? What else is coming? What is the AG group working on right now?
Well, I had a slide in that, and the basics are in place. The RIST simple, main, and advanced profile, the basics are in place. What we are moving forward now is the business of, we worked on all the ancillary features, but you're asking me about what's next, not what I've done so far, right? What are you going to do for me next? Satellite hybrid is an important one that is coming. It's addresses the problem of you know, the 5G is now encroaching on C-band, and I need to do something about that, and ways to use the internet for that. And then there's the whole thing about control and monitoring, which is something that my friend Adi is very involved in. So we need to look at that. And do you want to comment on control, monitoring, and that kind of stuff, Adi?
Before I talk about control and monitoring, I do want to explain to the people, RIST, the RIST specification, the work that we are doing is a result of people, companies, users coming to us and give us requirements. They have a wishful thinking, they want some kind of an application, they have a need. Can you solve that based on standard RFCs or standard work practices that will maintain the work that I did before? For example, the hybrid satellite IP came out of that, the multicast came out of that, adaptivity, security. Most of the features come from use cases that come and people describe what they need, what is the application, and how it will benefit their business. So that is how things come into fruition and specification rolling out to the market. The risk control is an activity that we are taking to basically unify the control, the overarching control of the establishment of risk tunnels and the traffic running through that. using using the specification of the RIST advanced profile, allowing better interoperability among vendors. Today, when you want to create something, you either go to a network management system, and there are many vendors that can that provide something like that, but each vendor has its own REST API, whatever. We want to have the capability of switching vendors. Maybe today you're working with Cobalt, tomorrow you want to switch to Evertz. You don't want to change your configuration and control protocols. And we want to make it as simple as possible to discover the vendors, their capabilities, to configure what is ever needed so that it will be much more plug and play. We are talking with other vendors and other groups in the industry to see what do they have to offer and how we can cooperate to find the best solution out there. And I won't mention which names we are talking with. Other activity that we are doing is we're also looking into venturing out. We have an activity looking into WebRTC, the use of RIST with WebRTC. I myself looking and talking with the folks from Google about the use of RIST with Quick. I even had a discussion with them just yesterday. So we are looking beyond the scope of regular operation. How do we converge protocols and bring more capabilities to the market for the users and applications of the future? Thank you.
Right. Thank you, Adi. Adi is a very active member of the RIST AG and has always very good ideas. But Susanna,
By the way, that's Adi Rosenberg, and he's CEO and founder of Alva Links. Just for those who are watching now and will be, downloading and watching this video later on.
Yeah. I want to comment on something too that you said, Susanna. 7 years, right? 7 years doing this. It takes time, but the reason is, if it was just me or Adi doing, we do it in a third of the time, but I don't think it will be as good because there's a lot of discussion. What about this? What about that? And when you build consensus like that, you get a stronger specification. So it takes time, but I think the final result is good.
Yeah, it's the result of the collaboration, and it's the best of the best, and that's why companies keep joining and companies keep appreciating everything that's out there on RIST, because you guys do it so perfectly and so completely. If anyone wants to join the RIST Forum, it's free. Please send me an email or send an email to info@rist.tv. If we have paying member levels, those are very important because it's obviously nonprofit. We collect very little money on an annual basis and spend every penny on all the wonderful marketing activities. We have presence at trade shows and marketing communications, articles, blogs, everything you see, all the activity, all the wonderful content has to be created and posted and delivered. So we have some expenses, not much, but we live and we exist because of the paying members. So if you want to start small with a few $100s a year or a couple $1,000s a year, there's different levels of memberships. And you can join and we can discuss it. And also, of course, there's free level of membership, which you can participate plenty and not need to contribute if it's not a good time for your company. So again, get in touch with me if you need anything or any of the members. And if you want anything and learn and see more information, please go to www.rist.tv. And everyone, speakers, thank you very much. Adi, participants, and thanks again for joining us. And in a couple of days, this should be posted on the YouTube channel. Thank you so much and have a lovely day.
Thank you.
Thank you.
Thanks, everyone. Have a good